Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in unit 4. We're going to see microprogrammed control of processor, right? In previous video we have seen how the control signal of the processor is generated using hardwired technique, and today we're going to see how the control signal of the processor is generated using microprogrammed control. Right, and this is a very interesting and important topic in unit 4. Right, and before going to this particular video, right, if you have not watched what is meant by hardwired control, how the control signal is generated, please go and watch the previous video. Only then you can able to understand this particular video. Right, so before starting with microprogrammed control, right, we have seen what is hardwired control. Right, hardwired control is nothing but based upon different inputs, right? The inputs from instruction register, the input from external circuits, the external inputs, the conditional codes, right? And step counter. Based upon all these inputs, right, it generates the control signals, right? And you know what is control signals? All the signals that is used in the instructions, right? PCN, ZN, all those things, right? So that control signal is generated, and based upon the control signal, the executions will take place, right? And similarly, today we're going to see about microprogrammed control, where instead of using different circuits, right, different elements, the control signal will be generated. The control unit will generate the control signal based upon the microprograms, right? Microprograms is nothing but zeros and ones, right? A set of instructions. Similar, like you already know, the processor fetch the instruction from the memory, right? The memory will have the list of instructions, right? Similarly, in microprogrammed control, we have a separate memory, right? A separate unit which stores all those microprograms, like microprograms, so that fetching that microprograms will give the control signal, right? So based upon the control signals, based upon the zeros and ones, the control signals will be generated. That is, based upon the microprograms, the control signal will be generated, right? And as a whole, microprogrammed control is nothing but the process of generating control signal based upon programs, microprograms which is fed, right? And before going to this topic in depth, you got to understand few important topics, right? Few important terminologies, that is code word. You got to understand what is meant by control word. Control word. You got to understand what is control word, right? And you got to understand micro routine. You got to understand what is micro routine, and you got to understand what is micro instruction. Control word, micro routine, micro instruction. Okay, I'll make it very clear for you, right? So before that, you can see that I'm taking the same example which we saw for the hardwired control, right? We have already seen how this particular instruction is executed in previous video, right? Please go and watch how this instruction is executed in previous video, right? So this particular instruction is nothing but like the addition of content of R3 and R1, right? And save it in R1, correct? So this is the steps, the instruction steps for this particular instruction, for executing this particular instruction, correct? Right, now we will see how microprogram control generates control signal for this particular list of instructions, okay? And now you got to understand very clearly, I already said, right, the instruction has to be fetched. First 3 steps, this is fetch phase, right? From PC, the instruction will reach the IR, right? And the next 4 steps is execution phase. You are clear with that, correct? Right. So in fetch phase, what will happen? The instruction is fetched from PC to IR, and only after the IR, it reaches the IR, it will execute, right? While executing, it generates the control signal and it performs all the operations, correct? Right. Now this is the set of instruction, right? What microprogram control will do? Microprogram control will not follow this instruction, right? It will create control signal based upon the microprograms, right? So what is microprograms? You can see here, this is the microprogram, right? This is the microprogram, right? The same 7 steps, right? The same 7 steps, right? you can see here the same 7 steps I have written in micro program, right? This is the micro program. Based upon this micro program, right, the control signal will be generated, right? I'll explain this, but before that you got to understand what is control word, right? For control word, what is control word is nothing but a sequence of zeros and ones, right? This is a control word, right? This is the control word. For PC in, you can see for PC in, this is the control word, right? So control word is nothing but a sequence of zeros and ones, right? That is called as control word, and only based upon the control word, the control signal will be getting generated, right? And you got to understand what is micro routine and what is micro instruction. Okay, so you can see here each and this is 7 steps, that is 7 instructions, correct? Right? This is 7 instructions, right? This is 7 instructions. Okay, we call this as program, right? We call this as program, right? Understand very clearly. This is program for this particular instruction, correct? Right? So the 7 steps is nothing but program for this particular instruction execution, right? And each and every step, this is called as instructions, correct? Right? And you know that the first 3 instruction is for fetch phase, right? Now you got to understand what is micro routine, right? You got to understand, right? 1, 2, 3. I say this as a fetch phase, right? In order to fetch the content from PC to IR, right? We have to use these 3 instructions, correct? Right. So these 3 combinedly can be called as micro routine, the complete steps, right? This is called as micro routine, and this instruction separately called as micro instruction, right? This is micro instruction, this is micro instruction, this is micro instruction, right? So how can I say this? This is the complete micro routine for this particular program, right? And each and every instruction is called micro instruction. You can see here, first step, this is 1 micro instruction, right? And this is 1 micro instruction, 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 and the last micro instruction, right? But all this are combinedly, why you have written? You have written it this for because of adding the content of R3 and R1, correct? Right? So this can be combinedly called as micro routine, right? So now you will be clear with what is control word, what is micro routine, what is micro instruction, right? So if you want to refer, you can refer here at the same instruction. You can see step one, right? What are the things is enabled here? PC out, MAR in, read, right? You can see here, right? PC out, MAR in, and read, right? The first step, all the 3 is enabled. Similarly, select 4, add, ZN, right? You can see here, select 4, select, add, ZN, right? All others are 0. And in step 2, what is enabled? In step 2, Z out, PC in, Y in, right? You can see here, Z out, PC in, Y in, right? Like this, the instruction will be changed into micro program, right? And this instruction, these micro programs will be stored in one particular memory, a special memory which is called as control store, right? Right? And in that control store, it is same like the processor. How the processor, what it will do? It will fetch the instruction one by one and it will execute, right? Similarly, right, the program, the micro program which is stored in the control store will be removed one by one. It will be fetched one by one and it will be starting executed, right? I'll explain that, right? And before that, whatever I explained here, everything has been given as a theory here, right? The control signal, right? You know, right now you understand what is control word, right? It is similarly to the machine language program, right? And similarly, right, it is a sequence of bits, right? That is zeros and one to represent one particular operation, right? And you know what is control word? What is control word? Right? What is micro routine and what is micro instruction? Correct? Right? And all those micro programs are stored in control store, as I said, right? And every instruction, as I said, every instruction will have its own micro routine, right? And micro routine is nothing but a combined instruction, a complete program that is called as micro routine. And every single instruction that is called as micro instructions. Correct? Right. Now I'll explain how this micro programmed control unit works. Right? And you can see here it's the same like that. You have instruction register, right, you have something called starting address generator, right, and you can see there is a micro programmed counter, right. This is not a program counter, this is micro programmed counter, right, micro program counter, right, and it is connected to the clock, right, and every clock cycle the micro program counter is incremented one by one, right, to go to the next instruction, right. And you know what is control store now? Control store, it is where the list of micro instruction, right, the control words will be stored, right. Right. Now you understand the operation of it. Like whenever the instruction is fetched, right? Whenever a new instruction is fetched in the IR, whenever a new instruction reaches the IR, right? Right? The starting address generator will generate the output to the program counter, right? The starting address generator is nothing but it will generate the address of that particular instruction. That's all. Okay. Right. It will the output of the starting generator given to the micro program counter, right? And once the micro program counter receives the instruction, the clock cycle, right, it will be increment to the next one, right? And once that particular instruction, right, reaches the micro program counter, right, for every clock cycle it will generate one particular instruction to the control store, right? The address generator generates the output of that particular address, right, and the PC will send to the control store, right? What the control store will do, the control store will have the list of programs, right, and for every clock cycle, right, the control word will be fetched from the control store, right, one by one, sequentially, right. In order to do that sequentially only, we are using a clock signal here. For every clock cycle, one control word is fetched from the control store, right. And now, based upon this control word, the control signal will be generated. Based upon the program, based upon the zeros and ones, the control signal will be generated, right. You know how the control signal will be generated? You can see here, if it is enabled, this is enabled, it will enable this control signal, PC out, MARN, read in, right. So based upon the programs which is stored in the control store, right, the control unit will generate the control signal, right. This is micro program control unit, that is generating the control signal based upon the micro programs which is saved, right. So whatever information which I've said, right, that is explained here, right. Right, control store, right, the program counter, right, it will store the information of all the code words, right, and it will be fetched sequentially, right, and whenever there is a new instruction, the starting address generator generates the address to the micro routine, right, the address is loaded to the micro program counter, and the micro program counter is automatically incremented for every clock cycle, right. This is what I have explained, okay, right. But this is a basic micro programmed control unit, right. What is basic micro program control unit, right? This is just what it will do, it will just execute the instruction, the code words from control words from one by one, right. That's the instruction it will do one by one, right. But whenever there is a branching operation, what is branching operation, right? There will not be a sequential operation, right? There will not be a sequential operation. While executing this particular instruction, suddenly it has to go to the some other location, right? And it has to go to the previous location, like that. That is called as branching instruction. If there is a branching instruction, what it will do, right? And if there is any external inputs, what it will do, right? The basic microprogram unit cannot handle the branching instructions, right? But in hardwired control, we have seen that in hardwired control, please go to the previous video and see that, right? In hardwired control, you will have external input and you'll have control codes, right? To generate, whenever there is a branching instruction, it will get all this information from this external inputs, right? Alright. So in order to execute the branching instruction, right, this basic control unit has to be modified, right? This has to be modified in such a way that it has to execute the branching instructions as well, right? So you know that normally in branching instruction, right, it will execute one particular instruction and it will go to the different location, right? So the processor has to understand, right? It should not execute the next instruction. It has to go to the branching instruction, the targeted address, correct? Right. So for that, what we have to do is we have to change this basic microprogram control unit, right? How it is changed, right? So you can see here, right? This is the changed microprogram control unit. In order to execute branching instruction, right? And I'll just explain this alone, then we'll go to the example, okay? You can see here, in order to execute the branching instruction, this is changed to starting and a branch address generator, right? But in previous diagram, what you have seen is a starting address generator. It will just generate the address of the instruction where it is going to execute, right? Where it is going to, which instruction it is going to execute, that address only it will generate, right? But here it is changed to starting and branch address generator. It will generate either starting address or branching address based upon the instruction which is received here, right? And all these things we have already seen, clock cycle, clock, and as well as microprogram unit, and you know how this function works, okay? And here we have something called external inputs and as well as conditional codes. That is, in order to facilitate branching operation, right, we use external inputs and conditional codes, right? Now we'll see one particular example, right? We have already seen this example, right? This example we have already seen, that is how to execute a branching instruction. We have already explained this in previous video. Just go through it, how to execute a branching instruction, okay? Right, so you can see here, this is the address of each and every instruction, right? 0, 1, 2, 3, and this is 25, 26, 27, right? And you know that the processor will, normally the processor will fetch the instruction one by one, 0, 1, 2, 3, unless or until it is a branching instruction, okay? Right, so if this is the branching instruction, we know that, right? And here what it will do, it will calculate the effective address, right? It will calculate the effective address here, right? Right, and it will add it to the PC, the updated address to the program counter, right? We have just seen how it will calculate the new address of the program counter, right? And then how it is sent to the program counter. We have already explained this in the previous video. Please go and watch, okay? Right, and here you can see here, as I said, this 3 once again is a fetching instruction, right? This 3 is a fetching instruction. Correct, right? And now you can see here, for one by one it will execute, and while executing this particular instruction, right, what is that? It is a branch to starting address, right? Branch to starting address. What does it mean? Now what will happen is, while executing this instruction, right, this particular starting address generator, what it will do, it will send number 25 to this particular program counter, right? You can see here it is sent to the 25, right? It should not go to the next one, it should go to the 25, because 25 is the target address, that is the branching instruction, right? Once again, while going to 25, right, while executing the 25, what it will do, it has to check the conditional branching, right? What is conditional branching? You can see here, conditional branching, if n is equal to 0, if n is equal to 0, right, it will check while executing that instruction, it will check, right, whether n is equal to 0. If n is equal to 0, right, what it will do, it will just reset and go to the first one, right? It will go to the address 0. What is address 0? It will go to this one. It will go to the next instruction, correct? It will start fetching the next instruction, right? Because n is equal to 0, the conditional is not satisfied, right? So it will go to the address 0, right? So what it will do, it will go to the 0 instruction, right? If not, if n is not equal to 0, then what it will do, it will go to the execute the 26, right? So it will generate the 26, right? And the 26, what is the control sequence for it? And that particular control signal will be generated, right? So you can see here, while executing the 26, what it has to do, it has to find out the offset value, right? It will calculate the offset value, right? And it will add to that particular value, correct? Right? We have already seen this example, correct? Right? It will add the original value of PC with this offset value, correct? Right? That is done here, that is computed here, right, in this instruction, and then it is sent to the Z in, correct? And from Z in it is sent to Z out, and then it is sent to the PC in, right? Right? So then it will execute 26 instruction, and then it will execute 27 instruction, right? Like that it goes on, right? And 27 instruction is nothing but what it does. It does Z out. It will enable the Z out and PC in, right? So that the content of Z out is sent to the PC in, right? So here you can see here. So while executing the branching instruction, right, it will look for the external inputs, right, and as well as the conditional codes, right? And whenever there is a branching instruction, it will go to that branching instruction, example 25, right? And once again, while executing the 25, it will check the branching it will check the conditional, right? If n is equal to 0, what it will go? It will go to the first operation, right? And start fetching the next instruction. If that condition is if n is not equal to 0, right, what will happen? It will go to the next one, right? And it will go to the next one. Like that, it goes on. But all the operation is same like the basic counter, right? Based upon the control words, it will generate the control signal, right? The control words will be fetched one by one based upon the clock signals. Clear? Right? So this is what I have explained, right, in this particular video. And you can see here, right, we have explained what is basic microprogram control unit, and we have seen how the changed microcontroller unit works. Okay, whatever I said, right, those instructions are given as a theory here, right? Basic operation, you can see external inputs, right, to determine the next micro instruction, right? And hardwired control, there is a logic, but here what we have to do, we have to go for conditional branching micro instruction. That is why we have to modify with the external input, conditional codes and all those things, correct? And I have already explained how it goes to location 25 and how it's target address and all those things, correct? Right? And I already said the PC is incremented every time, correct? That you got to understand one particular thing. The PC will be incremented for every step, right? Only if it is a normal instruction. Only if it is a normal instruction. If it is a branching instruction, what it has to do? It should not go to the next one, correct? Right? For example, you can see here in this instruction, here the PC will be incremented orderly, right? But here, after here, it should not go to the next instruction. It has to go to the 25, right? So the counter, the microprogram counter must not incremented for every clock cycle, right? For some other instruction, for branching instruction, it should not be incremented, right? So you can see here, for new instruction is loaded in IR, the microprogram is loaded with the starting address, right? Whenever there is normal instruction, the starting address will be loaded, right? And the PC count will be incremented, right? And if it is a branch instruction, what it has to do, the branch condition is satisfied. What it will do, program counter is loaded with the branch address. That is why here we use starting and branch address, right? If it is normal instruction, it will start with starting address, and if it is branch address, it will load the branch address, right? And each instruction is encoded, right? Whenever the instruction is encoded in the microprogram unit, right? One particular control word will be fetched from the control core, right? This is the control store, right? And based upon the control word, right, the control signal will be generated, right? So you can see here how the program counter works, right? Very simple. It will be incremented whenever there is normal instruction, and if it is branch instruction, it has to load the branch, right? So it will not be loaded, right? And then it has to go to the targeted address. And similarly, right, based upon the code word which has been fetched from the control store, the control signal will be generated, right? And the modified control unit will have external input, conditional codes, and the address generator is changed into, right, starting and branch address generator, correct? So today what we have seen is, we have seen how microprogram control unit works, right? We have already explained in previous video hardwired control, how it works, right? What is the difference between hardwired control and microprogram control? And this particular video explains about microprogrammed control, right? And how the control signal is generated based upon the microprograms, right? And you have to be very clear with code word, micro routine, micro instructions, and all those things, right? Hope you understand the logic. Thank you, students.
தேங்க்யூ ஸ்டூடெண்ட்ஸ், தேங்க்யூ ஃபார் வாட்சிங். கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். சப்ஸ்கிரைப் பேஷனேட் ப்ரொஃபஸர் அண்ட் கீப் லேர்னிங். தேங்க்யூ வெரி மச்.